Today, we're diving into a breakthrough that is completely changing the game for multiple sclerosis. It's a story that starts with a really tough medical mystery and ends with some incredible science that's finally offering a real solution.
Okay, just look at this number for a second. 16 years. Let that sink in. That's long enough for a newborn baby to grow up and learn how to drive a car. It's a huge chunk of anyone's life. But when you're talking about a serious medical condition, what on earth could 16 years represent?
Well, believe it or not, that's how long it can sometimes take to correct a misdiagnosis of MS. For up to 16 years, a person could be living with the wrong illness, getting the wrong treatments, all while facing a future filled with uncertainty. This one fact just shows you the massive challenge at the very heart of this disease. And that really brings us to the core of the problem here, which is the MS diagnosis challenge. So why has it been so hard for so long to give patients a clear, accurate answer? You see, a huge piece of the puzzle is that there's never been one single silver bullet test for MS. This has led to some pretty shocking misdiagnosis rates. Doctors have had to piece together clues from clinical symptoms and really complex imaging, and that can often be ambiguous and, unfortunately, lead to some big mistakes.
For decades, the best tool we've had for looking inside the brain has been the MRI. But, as we're about to see, scientists and doctors knew they had to find something better. They've been searching for something beyond just the scan.
And here's the thing, there's a real dilemma with MRIs. On the one hand, they are incredibly powerful. They give us those detailed brain images that are absolutely essential for making a diagnosis. But on the other hand, they're expensive, they take a long time, and for a lot of people, they are just incredibly stressful to go through. So all of this really drove the search for a simpler, less taxing alternative. And this is where the story gets really cool. Turns out, the solution isn't some bigger, fancier machine. It's something much smaller and honestly more elegant. We're now finding these critical clues hidden away in our own bodily fluids. So the key idea here is something called a fluid biomarker. Now, put simply, these are just measurable substances in your body, like proteins, that basically act like tiny little flags or signals for a specific disease. You can think of them like biological breadcrumbs that MS leaves behind, and now we finally have the tools to detect and measure them.
So how does this actually work? Well, imagine a nerve cell is like a building. When MS causes damage, it's like parts of that building's structure start to crumble. That debris, the biomarker, gets released into the spinal fluid, and eventually it makes its way into the bloodstream. And that means a simple blood test can let us measure that debris and get a remarkably clear picture of what's happening inside the brain.
And get this isn't just a theory. We've actually seen this work with stunning success in the real world. There's a condition called NMOSD that used to get mistaken for MS all the time. But when scientists discovered a specific biomarker for it, it was an absolute game changer. It allowed for correct diagnoses, which meant patients got the right therapy and avoided treatments that could have actually made them worse. It's a perfect example of the potential we're talking about.
But, MS is a bit more complex. It's probably not going to be a single biomarker that tells us the whole story. Instead, it's more like a detective using a whole bunch of different clues to solve a big case. We need a full toolkit of biomarkers, where each one has a very specific job to do. So let's meet some of the main players in this new toolkit. You've got biomarkers like oligoclonal bands, which are found in the cerebral spinal fluid, or CSF, and they're mainly used for that initial diagnosis. Then you have others, like kappa-free light chains, that could be found in either CSF or blood serum, and they help with both diagnosis and prognosis, which is just predicting how the disease might unfold. And then we have these really crucial ones, like NFL and GFAP, which are absolutely key for monitoring the disease over time.
Let's really zero in on one of the superstars of this new field, neurofilament light chain, or NFL. What makes NFL so incredibly powerful is that by measuring it, we get a direct window into how much nerve damage is actually happening, pretty much in real time.
And the concept here is so beautifully simple, yet it is so powerful. Low levels of NFL in the blood, that suggests less damage is happening. Higher levels, well, that's a really clear signal that there's more active damage going on with those nerve cells.
And this is where it really becomes a game changer for taking care of patients. By tracking NFL levels, doctors can start to predict future relapses and see where the disease is heading. And what's even better, if a patient starts a new treatment and their NFL levels start to drop, that's a fantastic sign that the therapy is actually working long before you might ever see a change on an MRI. So all of this is leading us to what this really means for the future. We're not just talking about a new test here. This is a fundamental shift in how we think about and approach MS care.
So, what does this all add up to? Why does this matter so much? Well, it means faster, more accurate diagnoses. It means being able to personalize treatments by predicting how the disease might progress for each individual. It means relying less on those stressful, costly MRIs. But the biggest thing, the most important takeaway, is that it allows for a shift from reactive care, where you wait for things to get worse, to proactive care, where you can actually step in and stop the damage before it happens.
And probably the most exciting part of this whole story? This isn't some far-off science fiction dream. While a lot of these biomarkers are still being researched, tests for neurofilament light chain are already here. They're clinically available, and doctors are using them today to help manage their patients' care. The revolution has already started.
Which leaves us with this one kind of mind-blowing question to think about. After decades of relying on complex machines and interpreting symptoms, could the future of managing diseases of the brain really, truly be found in something as simple and as profound as a single drop of blood?